What's up, guys? Calc 3 notes, notes in the infinite series. This is in conjunction with the telescoping series conversation. Specifically, we're talking here about number 73, number 75, some of the homework from 5.2, some things that you should work on. Here in this problem, the point for these types of questions is to just write them out. Remember that the relationship between the series conversation and the sequence conversation is that in a series you just add up all of the terms of the sequence before that value or up to that value. So like the partial sum S sub 2 is sequence elements 1 and 2 added together. S sub 3 is sequence elements 1, 2, and 3 added together, and sequence 4 is A sub 1, A sub 2, A sub 3, and A sub 4 all added together. But look at how it's kind of like nested, right? Like there's this connection or comparison, and it was brought up in class. Thank you very much for bringing it up. But it was brought up that the relationship between A sub n and S sub n is this what came before added together. So the partial sums can be increased or extended by adding the next sequence element to that partial sum of the series. Here's number 72, 5.2, number 75. We're looking to see if the series converges or diverges. So the way for us to consider that is to look at the gappage, like how does the partial sum increase every time? And is that increase growing, or is that increase getting smaller? If the increase between each partial sum is decreasing, then we know the partial sum, or the whole series actually, like as n approaches infinity, is going to eventually converge. But it'll converge to something like 2 or something like that. So we're looking at that here in this problem, or in this case, as you see it, look at it. It's always 1 minus a smaller and smaller and smaller and smaller fraction. So as the series is continued to be built and grown, we start to see that it's going to converge to 1. I was curious. What popped up in this problem was a 2, 6, 12, and 20 in the way that the next sequence term was added. So just to keep that in reminder, like you can go ahead and search up some of these facts, figures, information. Like these are common sequences. So there's documentation out there on the web that is not directly like, a carbon copy of the answers of the book, that will help you kind of see, some shortcuts or start to get an idea of like, oh, that pattern popped up. I need to be looking for those patterns, or know that that pattern might be identified somewhere else. Somewhere out there on the internet are all of these resources related to sequences. Okay, continuing on, we're looking to see what the sequence converges to. For number 75, the sequence converges to 1. Next question. I'm trying to put all these questions all into one video. A little bit longer than it typically is, but thank you for watching this video and for watching to this point right here. Number, I believe it's 79. And we'll see the work here get started in a second. The thing with number 79 is we're still determining based upon the partial sums to see if this series converges or diverges. So the way for us to do that is to look at the sequence elements, plug in a 1, plug in a 2, see what sort of results we're getting from adding them together. And if we get bigger and bigger and bigger terms every time, like the distance or the gappage between each sequence element is growing, then we have a series that diverges. And I am trying to throw around interchangeably, but also intentionally, the use of sequence versus series. Remember, series, you add up the sequence elements to that value. And a sequence is just how you define like item number 1, element number 1 to element number 2, and so on. Okay, so you can see in the work here, we've added the first 4 partial sums. Sometimes the series doesn't look like it's converging or diverging in the first 2 evaluations. We need to carry out our calculations to 3 and to 4, or until we can establish that there's a pattern, or until we can establish that the change between each partial sum is doing something that we recognize, like it's growing without bound, or it is reducing every single time, so that the series is getting bigger, but it's not getting bigger by as large as it did in the previous step, the previous partial sum. So we can also understand that that change, this is the other thing I want to highlight. I got it like, in somewhat red lettering there. That change is, or are, sequence elements. Because remember, a partial sum is the previous partial sum index-wise increased by a sequence element like a of n. So we should just consider, does a sub n increase over time? Thanks for watching the video. Hope it helped out. See you in the next one.